Inshallah, we are going to discuss today the solution of the higher differential equation. And the first step is that we are given a differential equation. Its order is higher than 1 because the last all discussion we have made for the solution of first order differential equation. We're going to apply that whole knowledge in solving this higher order differential equation. The idea is that we are given one solution. This is a second order differential equation, one solution is given. The method is how we can find the second solution, because as I told you, when it's second order differential equation, then our solution will be y is equal to c1 y1 plus c2 y2. Second order differential equation, we get here two arbitrary constants. So with that one we have two functions y1 and y2. First order differential equation we get only one arbitrary constant. Third order differential equation, we get here three arbitrary constants, y equal to c1 y1 plus c2 y2 plus c3 y3. So here there are two. So we are given y1, want to find y2, the second solution. So here is by you will find the second solution y2 by reduction of order. So the method for this one is that we are going to substitute here. Method is that we just substitute here y equal to u. We take the variable u1 uy1. So replace dy by dx and d2y by dx. Our dy by dx will be equal to, we take the product rule, u dy1 by dx plus we having here the y1 du by dx. So we take the, because y1 is a function of x, so it's very clear we are having the solution y1 is a function of x, so we can differentiate with respect to x. Now second one, we need d2y by dx square. We'll find here d2y by dx square. So we are going to get here, taking the derivative here, first function into derivative second function d2y1 over dx square. Then we have derivative the first function, this is equal to dy1 over dx into du by dx. Then plus we take derivative of y1, that is dy1 over dx into du by dx. Then we take the derivative of du by dx, get here y1 into d2u by dx square, and when we just simplify this one, we get here u d2y1 over dx square plus 2 dy1 over dx into du by dx plus we are having here y1 d2u by dx square. So when we substitute this one in our equation, then we get a situation that we can find that we can write here du by dx equal to new variable w, and d2u by dx square will be equal to the derivative of both the side dw by dx. And in this way we reduce the order of the differential equation. Then we solve it to find w. I will give you this with the help of example. We take this example and I show you how we're going to apply it. We're going to take this example and we want to show that y equal to x is solution of the differential equation. That means if this is a solution, this means we get here one solution, that's a y1. Then we want to find the second solution, and that we'll write the general solution as c1 y1 plus c2 y2. If you want to like it, here is written second solution, that means we want to find y2. So what do? We get here y is equal to u y1, this is my u, and my y1 is x. Sorry, first we check that this is the solution of differential equation. We substitute here, our y is equal to x, or y dash is equal to 1, or y double dash is equal to 0. Substitute in differential equation, I'll get here 0 minus y dash is 1, we get minus x. Then here y is equal to x, we are having here x is equal to 0. This implies y equal to x is a solution, is given solution because satisfying the differential. This is my y1. To find y, this is my step 1. So step 2, I take here y equal to u y1. This is my u and my y1 is x. This is my y dash. My y dash is first function derivative second, get here u plus x du by dx. Then here y double dash. Y double dash is equal to derivative of u is du by dx, And then here I get here plus x derivative. This one is d2x by d2u by dx square. And the derivative x is 1, we get here du by dx. We get only 3 terms because here the value with u is coming is 1 and the derivative is 1. We substitute in differential equation, multiply by x square here. We get here x square du by dx. Then we multiply by x square, we get plus x cube d2u by dx square. Then multiply x square, we get here plus x. This is du by dx has become here 2. I write here 2. Then I can just multiply this by minus x. I multiply minus x. We get here, this is minus xu minus x. We get minus x square du by dx. Then we are having here plus y. What's my y? My y is ux. Plus ux is equal to 0. Now we can see very easily that this is cancelled. Ux is cancelled with plus ux and minus ux are cancelled. And we rewrite with the higher term first. We get here x cube d2u by dx square plus 2x square du by dx. Then we have here minus x squared du by dx. This one is cancelled and we'll get here only x squared du by dx, and I put this equal to 0. Now the next is that I substitute du by dx is equal to w and d2u by dx square is equal to dw by dx. So we get here x cube dw by dx. Then we're having here plus x square. We have w equal to 0. As means we have reduced this equation to first order differential equation. That's the reduction of order. We started from this equation x square y double dash minus xy dash plus y equal to 0. And by our procedure, we change it to the first order differential equation. Now I can solve this one by separation of variable. I divide by x cube. I get here dw by dx, dw by x dx, plus get here w over x is equal to 0. I multiply here w over, here is no x, we divide by x cube. So multiply by dx and divide by w, get here dw over w plus dx over x. So is a variable separable form. We can just integrate both the sides. We get here dw over w plus integral dx over x equal to 0. The result I will get here ln of w plus ln of x is equal to ln of c or c. You can see it here. So get here wx ln is equal to ln of c. I'll get here wx is equal to c, or w is equal to c upon x. So I get here value of w. That's important. We must have the reduction. There must be some cancellation, and we get here only the term with du by dx and d2u by dx square. Then we can say we substitute and we can get the reduction of order. If it's not possible, this means there is some mistake. We have to correct it, or this method is not applied for that one. So here now get here this value of w. What's my w? My w is du by dx. So I get here du by dx. I substitute here the w is equal to, and that's equal to c upon x. So again separable variable, we having du is equal to c dx upon x. Again we integrate it, we get here u du is equal to c dx upon x, and here I take the value of x bigger than 0. It must not be equal to 0. So we don't need to write the absolute value here in this case. So get here u is equal to c ln of x. What's my u? My u, I substitute here in this equation, and this was my, I started with here, my new solution y2 was equal to u y1. That was my solution. And here we were having here, because our u was y1 was equal to x, and we have here then y equal to ux. So my y is equal to ux. Now I have the value of u. I substitute here. I get my y2. My y2 is equal to u y1, and it's equal to c. Y1 is x. U is ln of x. C x ln of x. We want to find my general solution. My general solution will be This is my constant, I can drop it because constant multiplied by constant with another constant. This is my second solution, is second solution that I want to find. Now I can write my general solution. So my general solution, as a note, we can write my general solution once I have the this is my solution, that's the general solution. That's y is equal to c1 y1 c2 y2. Because I'm having constant, I drop this constant, I get here c1 y1 is x plus c2 y2 is x ln of x, and that's my solution. And that's the idea. We just see the idea once again to demonstrate that in any equation, any problem given to you, you are given a solution, you're given the differential equation, second order. We use the reduction of order to get the general solution. That's find y2, and y1 is given, y2 we find, and then we can write the general solution. So here what we do, we find here y is equal to y2 is equal to u y1. U is unknown, u function, y1 is known. So we get here ux, substitute value of y1, y dash, y double dash, y dash, y double dash in the equation, and we get here x squared d2 u by dx squared plus x squared du by dx. Now we substitute du by dx equal to w, and d2 u by dx squared is equal to dw by dx, and we get this new equation, and this new equation is our first order linear differential equation. Reduction of order, this is the first order. So we reduce the order of the differential equation. We know the techniques for solving the first order differential equation. We use the separation variable. We get the value of w is c upon x. Now what's my w? My w is equal to du by dx. Instead of w, I write du by dx. Again, we get another first order linear differential equation, and we solve this first order linear differential equation by separation of variable. We get here u is equal to c ln of x. Now what's my y2? My y2 is u y1. What's my y1? My y1 is x. U I have calculated. This is my u, substitute here. I get here u c x ln of x is my second solution. I want to write the general solution. I always drop my constant because I have already one constant here. Constant into constant become another constant. So I get here c1x plus c2 ln of x. So I'll give you one more example for this one.